Okay, so then I will say let's get the session started. So most of the registered attendees are there now. And again, a warm welcome from the R3 team to this webinar or this web seminar today about EchoRing, the new industrial grade wireless. And we will present you today some interesting information. And that means, first of all, we want to introduce ourselves. My name is Bernd Kramer. I'm here at R3 as Head of Business Development. And a few words to my background. I was a couple of years in the industrial communication market in different roles. Concerned with industrial communication technology, and, both factory and process automation. It was about field level communication or shop floor communication, first days Profibus, later Profinet, as well as other Ethernet-based protocols. And in this field of end users and system integrators, I was responsible in various roles for business development or international sales and partner management. And earlier this year, I started the new endeavor here at R3, and I'm here responsible for business development, and will be your available contact beyond sales and product management. And therefore, I'm also the one doing this webinar session for you today. And the colleague with me is my boss, actually. So I will hand over to say him a couple of words about his background and experience and so on.
Yeah, hello everybody. Thanks, Bernd, for the introduction. Yeah, my name is Florian Bonanati. I'm one of the managing directors of R3 and also founder of the company. So we started the company 5 years ago, and so it has been quite a journey until now. And of course, we present to you today our product and what you can do with it. And basically in the last couple of years, I gathered a lot of experience primarily in the industrial and automation sector. Here at R3, I'm responsible for all the commercialization activities of R3, of the products and technology. And of course, over the years, there has been a quite wide range of client accounts I started to build up, and of course Bernd joins here and contributes quite a lot since he's here already. And it gives me a good overview of different industries. It's not just industrial automation, and there's also building automation, but also experience in other sectors like medical and avionics. And I think now we can go on and go deep into the content here.
Yeah, thank you, Florian. So you see very, very good conditions today. You will get answers to all your questions from first hand, so to say. And on the other hand, it's a great opportunity for Florian to talk to potential customers and to you. So we will go to the session now. Before we go to the content and the really agenda, some organizational stuff. How was the procedure today? Maybe not the first webinar for one or the other of yours. Let me say that you as participants are muted. It's not that we don't want to talk to you, but it's just to ensure good audio quality for everyone. And we have scheduled around 60 minutes for this web seminar in total, and we will do our best to keep the last 10 to 15 minutes for your questions. If you have questions during the session, if questions occur, you can type in those to this question area here. So if possible, we will have a look on that during the session and can maybe give some short answers during the presentation. Otherwise, we have then the couple minutes at the end to go really through the sessions we find in that area and give the answers as best as we can. If it's not possible because we run out of time or whatever, we will definitely get back after the webinar to you to give individually the answers you required. Even the slide deck, all the slides will be provided. So we will send you a quick follow-up email after this meeting today that you have the chance then later to pick certain slides or certain content you want to go deeper. So no need to note something or write something here, you will be provided with all the materials afterwards. Okay, the agenda for the meeting today, for the session today, is first topic. We structured this agenda in 3 topics somehow. Why is industrial grade wireless communication needed? So it's about background motivation for EchoRing, what means industrial grade wireless, what is about the requirements. The second topic will be then how EchoRing can meet those industrial requirements. We will talk about functions, properties, the scope of our solution. And as the third topic, last but not least, we will come in detail to the use cases, what use cases are covered, some examples, some details, and last but not least, also providing first steps. So what is the offer to you to get in touch with the technology and to make your own experience with EchoRing technology based on your own use cases in field. First topic, motivation for wireless communication. I mean, currently we see a big change in industrial automation, and therefore we provided here this graphic again. It's kind of yesterday, tomorrow perspective. Yesterday we had more static manufacturing, more inflexible, more cost intensive, more centralized production flow. Just the manufacturing lines with more or less no flexibility. And what happens now is a change to more flexible manufacturing, more mobile adaptive systems, more AGVs in place. And in addition to that, we have an increasing requirement or increasing demand for more data, for more real-time data, both in terms of process management and also in terms of production performance monitoring. So everyone is looking for how to get more data in real time and how to feed IIoT-based applications, whatever, to make the production lines, manufacturing lines more effective and to have a better output and a better quality. So it is a big change from more static communication lines to more flexible communication lines, and I think that is exactly the point where we step in with our EchoRing approach. We picked some use cases, some examples to display this challenge a bit better. And you see here some use cases where we are in already with the EchoRing technology. The first one is manufacturing intralogistics, bringing together cost efficiency, time, and performance. So in this case, we can help really with the EchoRing technology, and we do it already in current projects. The second use case is we picked here is heavy load transportation. If we have the need for synchronized moving of heavy loads, this is also a perfect use case where we can create quite a big value with our EchoRing technology. And the third one here is slip ring based data exchange. I mean, if you see packaging or liquid packaging, that are typically applications where we find slip ring based data exchange, data communication with the certain risk of mechanical risks and downtime risks, and there we can improve the performance significantly by using EchoRing. We will go later deeper to the use cases. This is just to have a little bit of idea in what directions we will talk also today. At this point, I would like, before we go more to the technology, I would like to give you a little bit of question, and because we want to know what is your background in terms of industrial wireless communication. So now you'll see 3 questions. We want to know about your experience, and just answer the questions. I will keep this a few seconds open that we have a little bit of better idea what is your experience on industrial wireless. So that looks quite good. We are right now at 70% of the attendees has done their choice. I will give you 1 couple more seconds. Okay, now we are at 90%. That looks good. So seems that's it. Seems we have the answer from everyone. Then I will close this and show you the result. And what you can see here is 22% is in a good shape, experienced with industrial wireless and also satisfied. But we have then 77% where we see space for improvement. That's good for us. So we will then we hope we can present then some alternative and good solutions. So that's a good response for us to see what the market situation is. Okay, good. Then at this point, I would hand over to Florian to go a little bit deeper to the technology background.
Yeah, thank you very much, Bernd. First, here is a little bit to go into details of the history of wireless communication, and especially the applications in the field where we envision to really have it and that it works. All of us are really right now mobile. I'd say everybody has nowadays experience with wireless. That's basically the first pillar basically here. It started in 2000 roughly with Wi-Fi, Bluetooth, Zigbee, and stuff like that got started. It developed over the time, and basically we're using it every day, and more. And of course, this is a great technology in general, and it brings convenience. But of course, our requirements are different to, let's say, machines or data exchange on a not between human to human level. So the next wave started basically more like what is called massive Internet of Things, connecting lots of devices with connecting them to send, let's say, small data packets. So large numbers, low power and cost. And this has been started out in 2010, something like that, getting into motion. Sigfox made a great development in the last years. LoRa, NB, IoT basically also started here, and it will be complemented or let's say added up by 5G in the future. So this is good. This is working. Large deployments out there, strong growth. What is not really there on the market yet, and it's less in a widespread, is what we call critical wireless communication, where you have two requirements to meet, especially, which is low latency and high reliability, in order to get a resilient system. And here we talk about especially clear machine-to-machine communication, more on the shop floor level between PLCs, programmable logic controllers, and let's say their inputs and outputs. You can talk about, of course, robots here. Let's say what happens inside of machines, and now in the future, of course, between, let's say, more mobile parts of a manufacturing floor. And this is actually where wireless plays out its strength, where you need to have mobility, and now battery-driven technologies are out there. So in a combination, and you see that HEVs, for example, that you can have such systems, and now they get into more, let's say, integrated into the manufacturing processes. And here, this is exactly where our EchoRing technology and of course our products will play a role. And besides, you also have 5G URLC upcoming, but let's say to get these numbers of latency and high reliability, this will take some time, especially the industrialization of 5G is not yet really started with that respect. Of course, in the consumer air domain, we talk about a different path, but in the industrial sector, when it comes to industrial grade modules, high availability of modules for the next 10 years and stuff like that. So this will come, but it takes quite a while from our perspective. So with our products and technology, this is a really good step in, and of course we will further develop our technology into better performance in the future. Bernd, can you click? I think I cannot do it. Oh, let me try. No, I can't. Bernd, would you click next?
I'll do that.
Somehow the rights did not transfer. Yeah, so when you look at the two flavors we optimize our systems for, this is latency and reliability. Other factors, let's say, like energy optimization, let's say for a smoke detector, which you have maybe 10 years, this is not the priority here. Typically, the machines we serve do have enough power connected to it for motors or other stuff. And so these are the two KPIs which are the most important here. And the problem gets really severe the further you go up in the upper right corner. The lower the latency, let's say the delay you can accept from your application, the lower that one is, the more complicated it gets in a wireless channel. And when you look back at the technologies I showed you at the slide before, these have been developed for human-to-human communication, where we do not really care about such short delays, short latencies. We are fine, let's say, with 100 milliseconds, 50 milliseconds, depends on the application. And we do not really care about how many packets are lost. So we could be fine with a Wi-Fi, which loses 1 out of 1,000 sent packets. When it comes to communication, like control communication on the shop floor, or even safety-related communication, or in a mixture, you need to move up here. And this gets now really complicated to run on a software basis in connection with a physical wireless link. And compared to a cable, this is a really challenge. And this is actually where we come into play with our products, and which we're going to talk later on. Yeah, please. Yeah, so when you map that with technologies, as I said, the technologies on the lower left-hand side, this is what you are used to, and you also know the limits of these technologies. Your Wi-Fi networks at home, they get better, but still you have problems here. If you, let's say, want to have really available communication, and even on the cellular network technologies, there are also limitations, and now and then we find that out, and this is not acceptable for technologies driven on the shop floor, for example. Yeah, and then you see these bubbles here, how we position ourselves as EchoRing, and also how it's positioned over 5G. And here you need to understand 5G follows releases, more like standardization milestones. And currently what you all hear about and potentially already use to some extent, depends on your mobile phone, is release 15, and release 15 is not developed for really dependable communication for shop floor. This will be by release 16, so later on, and we talk about 2 years until it's really productized on devices, maybe not on the base station, but on devices, which you need, of course. And we basically are here with a optimized solution already for these deployments, and this is basically the sweet spot we right now serve with our already industrialized products, and this is important. Yeah, so what is really making the difference with the technology we have implemented in such industrial device? So basically the wireless link is something which is, in this sense, unclear how good it is when you send something. So if your device sends out a packet, it is really unclear with what quality on the channel is to be expected, meaning, is there a good reception or bad reception? And this is influenced by many factors, where you are from the room, let's say, from other systems around you, reflections and so forth. So typically, in order to overcome that risk that you don't have a good reception on the first try when you send out information, a data packet, you typically retry, and with the first attempt. And now we already see. Can you click back, then, please? And when you look, for example, for a Wi-Fi, which is a centralized system with an access point, here the only thing which happens is time redundancy. You resend a packet, And there are some specific rules that the second attempt or the third attempt will take place longer. So the time between the attempts will increase by regulation. And if you take that now, this system in a system where you have fixed latencies to meet, this will be a huge problem. The second thing is you only have one path, and if this path is obstructed, and this could easily be happen on a shop floor. Think about moving robots. They have tools, they have grippers, parts to it, and they move all the time. So there may be also the point that you don't have a good connection because things are in the way. And this even makes it much more harder. And then you have a retry, and you typically can show from research perspective that if the first attempt did fail, the second attempt within the low latency time also will fail with a very, very high probability. And this is exactly what we overcome with EchoRing. And what we basically leverage is time and spatial redundancy. This means we do send, of course, the packet, the first attempt on the direct link. It always has the best chance to arrive. But in case this link is not working out, the next attempt will be routed in terms kind of a mesh, but it's a single hop mesh system in this sense, but controlled for latency. So a typical mesh system, you know the packet will arrive, but not in what time. And here we optimize here for a defined latency. And the great thing here is it's a cooperative system, so every node in that system can work. It works together. And on the one hand, maybe the lighter green path is the best path, and in another situation, because the robot, for example, has moved on, the other path is the best one. And leveraging that in a very highly sophisticated software architecture. So you think about, we need to meet reliabilities, losing maybe a packet 1 out of 1 million. So you can think about that this software, and I talk about the whole stack, of course, not only about the controlling the wireless chipset, is quite delicate. So, but we manage that in such a cooperative way. And this brings us the high guarantees we can basically bring with our products. And at the same time, coming from the guarantees, it's a dynamic system because it reacts basically on the instant situation. So before we send the packet in the first attempt, there is already the backup route defined. And there is no additional, let's say, processing needed or another node involved. So basically, the node who sends it defines also the partner node to cooperate with. And this makes it very strong and very flexible and dynamic, especially when it comes to changes on the shop floor and changes of the wireless network situation. I think now it's time over to hand back to Bernd.
Okay, then we wanted to share a little bit the content between us. Yeah, and the good message is exactly what Florian explained right now. And we are, if you see here on the left-hand side of this slide, it is not really the USI model. We want not to explain the whole USI model here today, but we are on the layer 2, let's say, and the MAC layer. So EchoRing is totally transparent to the higher layers, to the application layers where the several industrial protocols are running. And we have here again the overview about the market share of the protocols. This is this kind of HMS-based report, which is published every year. And I mean, that is a big advantage that we are, I mean, EchoRing is not a new protocol, but EchoRing is a new, let's say, option on the layer 2 to get the communication with several industrial protocols realized, so that you can really bring each protocol to a wireless quality. And that's what we did already in the projects. We have both Profinet as well as Ethernet IP projects, and so it's really the user, the end user, the manufacturer, or even the system integrator is totally open what kind of protocol is used depending on this application or this use case. But EchoRing as a kind of wireless alternative is always available for all the protocols. One note to EtherCAT, in case of EtherCAT use, it's limited to non-time synchronized communication between of the specification of EtherCAT, let's say. But all in all, that's a good and a big advantage, I guess, that you can really, where required from a use case, wireless communication, you can deploy this and can use it for several industrial protocols. If we pick out one of those, this is Profinet. I mean, this is typically Profinet architecture, like published in the PI organization, Profibus Profinet user group. And you see here such a typical Profinet architecture on the left-hand side here, the factory automation with the yellow color means safety components. We have robots here, we have motion control here on this area. So, and we are really totally open in case it is a value for you for application wise to switch from cable to wireless. We can step in and we can take care for the Profinet communication. So we will have the same or even higher reliability, but without cables in field. That is, let's say, the message here with EchoRing. Yeah, and we can provide multiple advantages to the several market segments, let's say. So if you see on the top here, the market segments, we see only one on the left side, the plant operator, production line, manufacturing. Then we go to system integrators and we talk to device manufacturers as well. And the value is quite different for each market segment. If you come from the plant operator perspective, the value is really simple deployment. So we have a hardware product in place, the EchoRing Ethernet bridge. We will talk about it later. And it's really simple to deploy in both greenfield and brownfield. So that means you can really go to currently running production lines or applications and can on demand change from wired to wireless communication. For system integrators, it's a big advantage that we deeply integrate this EchoRing technology to their own projects, let's say, depending on requirements from their end users. And for sure, we talk with the device manufacturer with the goal to implement quite deeply the EchoRing technology and enabling the device manufacturer to extend the own products with this communication interface, so that we have, in best case, these EchoRing wireless communication capabilities available kind of natively on the automation components, which are manufactured and delivered from the current players in the market. And the use cases then, as we said earlier, slip ring replacement, intralogistics, and from the device manufacturer perspective, again, really integration of radio links for moving parts within a machine. So the whole scope, let's say, from the end user to the device vendor is supported with the technology. And on the bottom line here, we have also, it's also to say that we have good cooperation already with Arrow as a partner for distribution in the market and also manufacturing services. And this long-lasting cooperation partnership with Texas Instruments. On the one hand, technical-wise, because on the TI Wi-Fi chip we implemented the EchoRing technology, and on the other hand, also regarding marketing, development, and customer projects, because all those customers or device manufacturers using these TI chips are, let's say, accessible for us, and they do have this using this way an easy access to the EchoRing technology as well. And accordingly to these several market segments, we have here displayed again the scope of availability of the technology. That's what I said earlier on the left-hand side here. You see this hardware product, let's say our Ethernet EchoRing Ethernet bridge. This is this kind of device what can be used in field. Then it goes further to the system on module approach. Let's say on the level where system integrators can integrate this technology in their components, and it goes until software integration. So really deeply software integration of the EchoRing software stack, and that is our, let's say, business case and our our model, what we go with several automation component manufacturers. Okay, we want to focus now in the next slides a bit more of on the left side here on the EchoRing Ethernet bridge, because this is, from our perspective, the quickest and best step to get closer to the technology and get your own experience with that. So I think, Florian, this is again the part you wanted to explain a bit deeper.
Yeah, sorry, it's one more back. Here we go. Okay, yeah, perfect. Yeah, so it's our current flagship product, of course, and I think it's great when it comes to the flexibility of that product. So first, in that product, we implemented a whole URLLC stack. This means from the Ethernet interface, which is here conveyed over M.2, M12 interface, sorry, goes exactly from, let's say, this perspective of reliability and low latency through the stack, through the wireless, through the EchoRing protocols, to the other side and back. And this is quite important because this, if you integrate it or use it with your products, you don't need to take care about that. And everything is here optimized on the whole stack. Second, it brings us, of course, a lot of interfacing opportunities, and Bernd mentioned that a couple of slides before, that when it comes to this product, we can run Ethernet-based protocols, which are widespread in industry, and you probably all know them. Ethernet IP when it comes to Rockwell, Profinet systems originated from Siemens, PowerLink when it comes from B&R, CC-Link when it's more like coming from Mitsubishi, and so forth. So with this product, you have a very great flexibility to convey these messages you typically use, leverage your cable-based communication. The product itself right now is certified for CE and FCC, meaning European and North American markets. China is in the process. Second important aspect is that it's an IP65 housing, so you can use it really on the shop floor. You don't need to put it into a switching cabinet. Of course, you can still put it onto a switching cabinet, but it also works outside. So we don't discriminate between these two sides. The range depends now a little bit on the regulatory aspects. Under FCC, we can build up networks to 80 meters. In Europe, we typically talk about 20 to 30 meters, depending on your reliability requirements. I say it does not really matter how far you can go. The question is how flexible you can scale up your networks. Typically, we focus on smaller cells with a smaller range and connect them if it's necessary, if you have such a high range to cover with a seamless roaming technology. This applies, for example, for all the HEV or intralogistic use cases you currently run. The data rate right now is at roughly 6 Mbits guaranteed, so which is available for the application. That doesn't mean that you can still send best effort traffic over it. So this is there's still capacity in it, but this is really the data rate which is guaranteed by the configuration. And now, of course, it depends on how you distribute that potential data into bigger packets, smaller packets, smaller, higher cycle times, or number of nodes in such a network. We also have security on board, which is important, but not everybody needs it. So this is quite, let's say, depending on the application and their location. The second last thing here is to point out, it also runs with PoE. So you can use 24 volt directly, or we can power it by PoE. So that gives also high flexibility, especially when it comes to mounting on the infrastructure side, where PoE is quite widespread when you think about access points, which you find everywhere, maybe from Cisco, also in on a manufacturing floor. And last but not least, as a feature to point out, besides many others, is fast boot option. So we have a version, it's not a standard version, but this can boot up in 3 seconds, and the Profinet system is already running. And this is quite important when it comes to, let's say, interesting applications on the shop floor with robots and tools. Yeah, so the tools is here also to shortly told. Configuration server, of course, we how you can configure the networks. We have tools which we call Health Monitor, which gives you kind of a mobile device to understand what's happening in the network. That means, for example, for when you install it, but also later on when you have, let's say you're in operation and you want to see if everything's fine, or later on to diagnose if maybe there is something wrong with the wireless, or maybe not. We give you performance analyzers in order to set up your application quite fast without accessing your applications. Performance analyzers basically build up a, let's say, configurable PLC basically, and where you can imitate the same traffic your application has, but without, let's say, interrupting your system, so you can run it in parallel and see if what you want to achieve can be achieved without, let's say, investing too much in a real setup. And of course, as this is all software triggered, so here only standard commercial off-the-shelf components, industrial components, of course, are used. The value add here is software based purely, and we have a huge pile up of new features we will run in the next years. So if your application changes, we will have, of course, potential to update your system with the features you need. I will hand over to Ben, please.
Yeah, okay, then we will go deeper to the use cases again. That's what we started with at the beginning. So here we just showing again the use cases in field we are in place right now with EchoRing, and one of the first and the most important is AGV control and collaboration. It is there about reliable real-time communication. Quite often we have harsh industrial environments, and what we could reach there, it's significantly reduced setup times when changing lines and so on. And yeah, this results finally in reduced total cost of ownership for sure. And the second one is robot tool changing.
Just one comment here, just to make it clear why we have that on it, because typically you would say, well, I can control my AGV via wireless, they're safe anyway. What we learn, and there is a high need to have a central safety control. So it's not about the safety of the systems itself. They're safe by design, but it's about really controlling smaller cells basically from a central perspective.
Yeah.
And this is where the wireless is very important that it works. And this is what we here contribute.
Therefore, Florian, that's totally right. Therefore, we have provided the next slide where we go to this use case a little bit deeper then with the safety thing. So that's correct. Yeah. The second one here is, as I said, robot tool changing, wireless communication between robot and tool holder. It's about maintenance costs, maintenance time slots, and operating costs. And on the right hand side here again, the slip ring based data exchange we talked about already. Elimination of the risk of failure due to mechanical wear and tear. So finally we can, with this wireless EchoRing communication, we can make the applications more sustainable and more efficient, and even more comfortable in use, let's say. And especially this left one here, AGV control and collaboration, is here again a reference, let's say. It's a little bit an abstract graphic here, but Florian, maybe you can explain this a bit more, because I think this is a site where you has been already, and just a few words more to this real case we have equipped with EchoRing.
Yeah, thanks. Yeah, I think the big message here is we talk not only about small deployments where maybe you have a couple of nodes to cover, or maybe even a point to point, but also our technology is there and made there also to scale. And this is an example of a scaled deployment we are currently running. Start of production is beginning of next year, so this project takes some time, but it's not only the wireless part which needs to be done. And here the interesting thing is, and as I said, it's about safety here. It's not only control of the workstations, which are basically mobile here. It's also about the safety control from a central PLC. And this is a request we engaged quite often in the last couple of, let's say, months, especially. So this has picked up that this is a need, and now what we bring here is that we are able to manage a large-scale network. So it's not only, let's say, managing the wireless link, but also managing this network. So these devices are in one cell in one time, but then they leave this wireless area and go to another area. And there are some areas where we don't need to have, for example, connection, but basically on the return line and loading line, there needs to be also data exchange, which is not safety or control critical, but there is data exchange. And in this sense, we're able to really deploy large networks. And as I said, the seamless roaming, which we offer here, plays here its role and its features, that we can have, let's say, smaller networks support really high requirements for these devices here, and we can portionize them in really small cells and just connect them via our technology, and they never lose their minimum guarantees they need to have. And this is quite attractive, and and quite extraordinary, and this is also how we won that project.
Yeah. Okay. Good. Then time-wise, we are still good. We have 15 minutes left, so I will do the next topics maybe a bit faster, that we have enough time for your questions. But yeah, this is the answer. Yeah, first steps towards EchoRing. So how to get in touch with the product, how to make your own experience with this technology. The goal from our perspective is, for sure, to provide you an easy way to gain insight into performance and compatibility of EchoRing related to your own application. Not only, okay, this is a demo rack and this is the way it works, but really bring the product to your own application, to your own use cases, and evaluate how does it work and what kind of advantages you can leverage. So therefore, we have created an offer. This is, on the one hand, this hardware set. So we created a so-called ECHORING Rollout Package. It's a kind of product set that contains all components and accessories and everything that you got packed box, let's say, and then you can start deploying in the field and start working on several use cases. And this is guided by your special service and support engagement. Let's say we talk about an 8-week entry program, so to say, accompanied by R3 experts. So we start with a workshop. It might be an on-site or remote to get you introduced again in detail to the EchoRing technology and discussing really in detail your use case. And then during this entry program, the first weeks, we provide additionally application-oriented technical support for just optimizing EchoRing to a use case scenario. So you will get the first experiences, you will get more questions maybe, and therefore we in place then to get this question answered. The components, I think Florian talked about briefly at the EchoRing Ethernet bridge slide. We have 5 of those units. That's the core, let's say, of the package. That means you have 5 nodes. You can realize 5 nodes to EchoRing communication. We have the performance analyzer hardware inside the installation assistant to assist you during the network setup. Also to generate simulated traffic before you start with your real traffic, and also for gathering data for network configuration and optimization. The health monitor, as Florian mentioned earlier, it's a kind of network visualizer, visualizing the network traffic, generating reports, even create suggestions for network optimizations again, because you can imagine it's quite important to do the right and good configuration to have really the reliability you want to reach with this technology. And also the config server, configuration server, the single microcomputer that runs a GUI on it to configure the network for testing and operation. So this is the whole package of accessory devices, let's say, to get your first EchoRing network running in field. And how does it look like? So we have here the components again listed, five bridges, cable, power cable, Ethernet cable, that's it, all those things. So we just wanted to make sure that you have everything in the box you need and that you can start quite quickly and getting our support and getting quite quick your first experience using this technology in your use cases. Timeline-wise, it starts with installation again, technical workshops. We support you during the operation evaluation phase, and for sure we want to have the kind of assessment meetings then during the process and even at the end as a final assessment. For sure, it's for us important to learn about your use cases and to understand really your application scenarios and the value that we can provide. So therefore, it's a really this kind of rollout kit offer that we have. It's kind of combination between hardware, software on one side and really one-to-one support and consulting on the other side. So that, and the first projects we did that way were quite successful, and as well was quite well accepted from customer side that we have this support beyond the pure product, let's say. Yeah, after this first introduction via web meeting here, next steps, what to do next, our proposals on how to proceed. The first thing is for sure, you can schedule individual web meetings with us for further clarification, so we can dive deeper even to your special use case or individual use case. You can choose such appointments at any available time slot upon request. And we will provide even a second web seminar like this with a more practical approach. So everyone is invited to join the second session as well. This will be held on week 33, I guess, once the main vacation time is done and all our technical colleagues are available again. So we will send out a separate information for that, and please make use of this session, because there we will really go deeper to the installation, deployment, look and feel of the graphical user interfaces, what to do, what steps, and so on. And the other cases, for sure, if you are right now ready to go deeper or to closer to the product, then for sure we provide this rollout kit. For that, you can go at any time to our sales via the given email address here, just request for a quote or just request for more information. We have detailed product information again about the components with more technical details and so on. So both ways are possible. Get more information or just get in touch directly to get your own rollout kit and to get your own experience with your first EchoRing network in the field. Okay, that's it from the slide. Content-wise, let's say, we have now almost 10 minutes for questions and answers. And I see here in the question area, we do have one already. Florian, would you take care of that?
Yeah, so I even got more questions, that's 3. So I start with the first one. So here the question is single carrier versus multi-carrier approaches. So first, of course, I'm not doing research here, and maybe this is a question which we can intensively discuss with one of our co-founder, James, who is professor at the KTH in Sweden. But just to give you a short answer, so first, we don't change the physical layer of Wi-Fi. That's the first. So we take a standard Wi-Fi chipset and we change completely the MAC protocol layer. And of course, as I said, we also bring in URLLC stacks until to the application layers. That's the first thing. The second thing is to multi-carrier modulation. I understand you're talking about something like what LTE is already doing, OFDMR basically, I assume, or maybe Wi-Fi 6 is also leveraging. I'm not sure what is better, but when it comes now to really high reliabilities, I only can tell you that even the release 16, when it comes to 5G, goes the way of spatial redundancy. So so they don't stick to what, let's say, modulation scheme they can do, but they go to the same approach we have here, where you use potentially time or frequency redundancy, but also at the same time spatial redundancy, taking different paths into account. And I would say this is a good pointer that this is an important direction you need to take, and not depending on, let's say, it's a single carrier or multi-carrier modulation. I hope this gives you at least some answer, and that we are doing something which even 5G will do in the future. So I'm talking about especially the coordinated multi-point solutions or tests which have been done by Qualcomm. I hope that gives you an answer to that. Maybe last comment here. It's also important to have a very easy module to integrate on a device side. And of course, the complexer you go here, and let's say more modulation schemes and more complex control, things get also more complex on the device side. On the access point side, of course, you know all these very high dense technology is put into these, but on the device side, we believe that it's very important that you have a very simple, cheap integration. And this is actually what we bring in here with EchoRing, running on a 802.11n PHY currently. I hope this answers you at least some questions. Please, if you have more, let's say, research details to discuss, of course, we can do that, but maybe I'm not the right person to do it with you.
I think you got the confirmation already, Florian, that the answer was good. But
okay, I haven't seen that.
Just let me mention, we will put the questions also on the slide deck, and the answers then afterwards you will provide this content as well.
So then we have a second question here with respect to safety, industrial safety. So first, our system provides you a communication link, which is typically considered as a black channel. So we do not certify our link, wireless link, for safety. The same applies basically to cable. So Ethernet cable is not safe or not certified as safe. So we are part of the black channel, and what we bring in here is a high availability of communication. And if you take in safety into account, of course your application, your system needs to be safe, but there are typically higher layer protocols, for example, ProfiSafe or SIP safety when it comes to Ethernet IP, which take care of that. So they basically decide, is everything fine or do we need to stop the machine? And one reason why the machine is maybe stopped is because the communication fails. And here our technology comes into play, and with the features I try to explain, at least to some degree, we guarantee basically high availability of such a communication link over the wireless. And this is basically what we do. So we support with our technology, with our wireless technology, industrial safety applications where the communication packets are safe, and we convey them to the destination where it needs to be in the right time. I hope that so what we use as frequency band. So right now, so basically our technology is independent of the physical layer. This means it could run on the top of any frequency in general. Of course, every frequency comes in with specific features or KPIs. Let's put it like that. Right now, our core product runs on a 802.11 PHY N. With that product, we can access from the hardware 2.4 gigahertz and everything between 4.9 and 5.9 gigahertz. Of course, depending on the local regulation, not every frequency band can be run with our specific medium access control. In addition, we are working on products which hopefully will be shown as a POC, or let's say as early trials end of this year, to tune into 5G bandwidth, especially when it comes to campus bands. So I'm talking about a range from 3.5 to 4.2. And also we will go already with that hardware we're right now working on into the 6 gigahertz band, which is currently open now in the US as a new Wi-Fi band, and will be open in the European Union potentially mid-end of next year. Then there's another question over power line communication. Yeah, of course, the protocol could work like that. But the main feature here is, of course, we are in a broadcast scheme, and the repetitions, basically the cooperative repetition, needs to play its way. So yeah, the medium access you could leverage on a power line. That's true, but so really we are leveraging in our core technology in the broadcast field. The minimal bandwidth requires from the PHY. Yeah, again, well, we could work with basically every PHY. So the EchoRing could run with a 1 megahertz, with a 5 megahertz, with a 10, with a 20, with a 6, with the 80 or 160 megahertz channel. The question is, can it convey enough data what the application needs? So what we learned right now is that with the 20 megahertz we currently deploy here at customers, that's a good spot, because via that we have we can offer data rates which are required from Profinet and stuff like that. Let's say Ethernet-based protocols. And it also is fine when it comes to channel management on industrial sites or, let's say, automotive deployments. So there it will be hard anyway to get a channel with 160 megahertz. So I don't see that advantage there, especially because the wireless channel is scarcity. So 20 megahertz is quite good. And with the roaming technology, we can basically breathe in here. So we can have smaller deployments and connect just the same channel again a couple of meters further away. So we can breathe the 20 megahertz quite well. And when it comes to, let's say, smaller bandwidth, this is quite limiting, but because still the packet sizes of a Profinet can go up to 300 bytes or something like that, depends on your application, and then it will be difficult with other physical layer technologies.
Okay, thank you, Florian. Then it looks we are perfect in time, and yeah, as I said earlier, we will provide you with all the information. You will get an email with the record and with the slide deck even. So then it's just for me say thank you for coming and thank you for your audience. And yeah, let's get in touch one-to-one if you need more from us. And for now, for today, have a great day and a great evening, and bye-bye from our side.
Thank you all for listening. Bye-bye.